This video discusses the intermediate value theorem. The intermediate value theorem for polynomials states, if we let f be a polynomial function with real coefficients, if f of a and f of b have opposite signs, then there is at least one value c in the open interval ab such that f of c equals 0. Let me draw you a picture to help explain that. So f of a and f of b are y values. So we have two y values that are opposite signs. So here's where x is equal to a, and here's where x is equal to b. And their corresponding y values of f of a and f of b. So intermediate value theorem says if you have these two y values that are opposite sign, one positive and one negative, then there has to be at least one x value c in between a and b such that f of c equals 0. So basically, with a continuous function, which a polynomial is, you can't go from a negative y value to a positive y value without having a y value of 0 somewhere in between. Now, we can conclude that there is a real 0 in between a and b if they have opposite signs. However, if f of a and f of b have the same signs, it's inconclusive whether or not there is a real 0 in the interval ab. Maybe yes, maybe no. Let me draw you two different pictures to show you how it could be maybe yes, maybe no. So we could have a graph that looked like this. We have a positive f of a and a positive f of b. So this one actually has two spots where it hits 0 in between a and b. But we could also have a graph that looked like this. Here, f of a and f of b are both positive, but there is not a 0 in between a and b. There isn't an x value where our graph dips down and hits the x-axis. So it's inconclusive if the two y values are the same. If they're opposite, we can say yes for sure. So let's use intermediate value theorem to determine whether or not the polynomial function h of x equals x to the fourth plus 6x to the third minus 18x squared has a real 0 in the interval ab, which happens to be 3, 2 here. All we need to do is find h of 2, h of 3, and then compare them. If they have opposite signs, then yes, there's a real 0 in between. If they have the same sign, it's going to be inconclusive. So let's find h of 2. All you need to do is plug this in your calculator. H of 2 gives us -8. We'll do the same thing, finding h of 3, plugging it in. And then putting that right into our calculator. We get positive 81. Now it's time to compare. H of 2 is -8. H of 3 is positive 81. Here we have opposite signs for our two y values. intermediate value theorem says that if our two y values have opposite signs, then there has to be a real zero in between the two x values. So yes, there is a real zero in the interval 2, 3. Now you'll notice that the given interval had square brackets on it, including the endpoints, but when we write our answer, we need to use an open interval, having parentheses on it. Because what we're doing here is saying that there's a real zero in between 2 and 3, therefore we cannot include either 2 or 3. Let's try another one. Determine whether or not the polynomial function g of x equal to 2x to the third minus 16x squared plus 18x plus 5 has a real zero in the interval 3, 4. Again, we're going to find g of 3, g of 4, and then compare their signs. Plugging in 3. And then plugging that into our calculator, we get negative 31. Next, we'll plug in 4. And plug all that into our calculator, we get negative 51. So g of 3, negative 31, g of 4, negative 51. Here we have the same signs. Well, intermediate value theorem only says that there is a real zero if there are opposite signs. So here it's inconclusive. And that's what we're going to write. It is inconclusive. Whether or not there is a real zero in our interval 3, 4.